Welcome to today's online lecture. The topic of today's online lecture will be assessing categorical syllogisms from the Boolean stance, but just to to reconnect with what we talked about last time. Last time what I taught you was how to classify categorical syllogisms, right? So basically, and we define them as well. So a long story short is that a categorical syllogism is any argument with exactly two premises, and it contains only categorical propositions. A categorical proposition is a proposition that has a subject term, quantifier, subject term, the verb to be, a qualifier, and then the predicate term, right? And so altogether, we saw that there are four building blocks, as it were, for categorical syllogisms, four kinds of categorical propositions. And we'll go over that in a minute, over the four kinds. So if you want to identify categorical syllogism, you classify it according to its mood, which involves the kinds of uh, categorical propositions it involves, and according to its figure, which tells you how the middle term is configured in the syllogism. So just to review from last time, remember that a syllogism, categorical syllogism, contains three terms altogether. The minor term, which is the subject of the conclusion, and it occurs in the second premise. And then there's the major term, which is the predicate of the conclusion. It occurs in the first premise. And then the middle term occurs in both premises, but not in the conclusion. All right. So every categorical syllogism contains three categorical propositions, and it contains three terms: the minor, the middle, and the major. And they're configured in one of four ways. And if you remember from last time, the four ways are as follows. There's figure one, where the middle term is configured in a diagonal to my left facing the screen, right? So MP, SM, SP. So notice again, the middle term occurs only in the premises, but not in the conclusion. The second figure involves the middle term being the predicate of both premises, P-M, S-M, S-P. In the third figure, the middle term occurs as the subject of both premises, M-P, M-S, S-P. And then finally, figure four involves the middle term occurring in a diagonal, but this time in the opposite direction to the first figure. Now it's a diagonal to my right facing the screen, right? So P-M, M-S, S-P. So there are four figures of the syllogism, and there are 64 syllogisms in each figure, right? Now, therefore, we need a more fine-grained way of distinguishing syllogisms. So we distinguish them not just in terms of the figure, but the mood, which involves the kind of categorical propositions that are involved, right? Okay. So if you look here, this is a categorical syllogism. All mammals are warm-blooded. All mammals are animals. All animals are warm-blooded. Notice here that the middle term is mammals, and it occurs as a subject of both premises, so it is therefore figure three. And then the predicate term and the conclusion, warm-blooded, is in the first premise, and the subject of the conclusion is in the second premise, right? And so this then turns out to be a figure three syllogism, and the mood involves the kinds of categorical propositions that are involved. So here we have all, and all, so it's AAA dash three, right? So it's an AAA dash three. If you look at the syllogism below this, some animals are mammals, all mammals are warm-blooded. Some warm-blooded creatures are animals. So notice that this syllogism, the diagonal is in a direction of the middle term is in a direction facing my right as I face the screen. So therefore, this is a figure four syllogism, and the mood is I, A, I, right? So it's I-4. Okay, so that's how you classify the syllogisms. And remember that I said that it's kind of like analogous to DNA with the four nucleotides that make up DNA molecules, right? Same thing with the categorical proposition. You have four kinds. Each categorical proposition contains a quantifier, a subject term, the verb to be, a qualifier, if applicable, and a predicate term. So if you look here, some animals are not mammals. This is a categorical proposition. Some is a quantifier, and animals is the subject, the verb to be, then not is a qualifier, it's a negative proposition, and we have then mammals as a predicate. So this proposition is called a particular negative, right? Okay, so altogether, as we saw last time, there are four kinds of categorical propositions. Altogether, all S's or P's is a universal affirmative. No S's or P's is a universal negative. Some S's or P's is a particular affirmative. Some S's or not P's is a particular negative. All right. So those are the four kinds of propositions that make up a categorical syllogism. And remember, we looked at how to diagram the categorical propositions. So, for example, all S's are P's. You shade in everything in S that doesn't intersect with P, and that says that anything is an S is also a P. That's how you diagram all S's or P's, the A proposition. Then we saw that for the E proposition, no S's or P's. You shade in the area of intersection between S and P, and that tells us that nothing is both an S and a P. That is no S's or P's. That's the universal negative, okay? Then you have the particular affirmative. Some S's or P's, we put a next in the area of intersection to say that there's at least one thing that is both an S and a P. And finally, some S's are not P's, we put a next in the area of S that's outside of P to tell us that there are some S's that are not P's, all right? And so that's how you can represent the meaning of categorical propositions. Okay, so anyway, and then what we did is we just took all this, the different categorical propositions, the mood and figures, and we were able to classify categorical propositions. So again, if you look at this one on this slide, all um, okay, all mammals are animals, all humans are mammals, all humans are animals. We see that again, mammal is configured in a diagonal pointing to my left, right? And so it's a figure one syllogism, and all three propositions are A. So it's A major premise, right? A minor premise, A conclusion, figure one. Okay. So, and that's what we have in the next slide. Okay, now consider the following syllogism. We have some mammals are animals, some humans are not mammals, some humans are not animals. We see that this syllogism, that the word mammal is again a diagonal configured towards my left, and so it is a figure one syllogism. And the first proposition, some mammals are animals, that's the major proposition, is I. The second proposition is O, some humans are not mammals. And the conclusion is O, some humans are not animals. So this is I-O-O-1. So as I say here at the bottom, there are 64 possible moods for each figure, and hence there are 64 times 4, or 256 possible forms a syllogism can assume. Let's see. Oh boy. Sorry there, I just had to tend to my dog. My apologies. Anyway, so that's it. So that's what we covered last week. Okay, so now what we need to do is move on to how to assess categorical syllogisms. So we'll do that next. So let me stop sharing this slide here, and we'll go to the next PowerPoint. Okay, so let's go to the next PowerPoint. So again, I'm going to do share, and that will be syllogisms too. And so this is the PowerPoint that we're going to focus on this evening, and it's going to tell us how to assess categorical syllogisms, right? From the Boolean stance. Remember last week I distinguished between what is called the Boolean stance and the Aristotelian stance. So those are two um, different ways of those are two different ways of evaluating categorical syllogisms. The Boolean stance does not make any existence presuppositions with respect to the S term. And so all that you have with the Boolean stance are what are called contradictories. You don't have contraries and subcontraries. So what we're going to be looking at this week is how to assess categorical syllogisms using the Boolean stance, okay? And we're going to use two techniques. for assessing categorical syllogisms using the Boolean stance. One is the Venn diagram technique, and that involves, again, diagramming the different propositions in the syllogism. And then there's the rule technique, all right? And the two techniques are equivalent. You're going to get exactly the same results using either technique, the rule technique and the Venn diagram technique, okay? They're exactly the same. So what I'm going to teach you this evening then is how to diagram a complete syllogism from the Boolean stance, and then how to assess it to see whether or not it's valid or it's invalid, okay? And then what we're going to do after that is I'm going to use the rule technique, and we'll see again how to determine whether or not the syllogism is valid or invalid using the rule technique. And again, the Venn diagram technique is equivalent to the rule technique, okay? So that's what we're up to with this online lecture. Okay, so suppose I want to evaluate the following categorical syllogism, okay? So this syllogism then is as follows. Premise, all animals are mortal. Premise, all mammals are animals. And the conclusion is all mammals are mortal. So notice then that the middle term is animals, and it's a diagonal in the direction facing my left. And so it is a figure one syllogism, and all three propositions are A's. So it's A dash one. Okay. So in the assignment that I'm posting for this, that you need to hand in this Thursday, I'm going to ask you to do three things. One, tell me what mood and figure the syllogism is that you're assessing. That's the first thing. The second thing is to then use either the Venn diagram technique or the rule technique to assess the syllogism for validity. Okay. Remember that a categorical syllogism is valid if it's impossible for the premises to be true and the conclusion false. And a syllogism is invalid if it is possible for the premises to be true and the conclusion false. And you can find that out using either the Venn diagram technique or using the rule technique. So here are the steps for evaluating this syllogism here, AAA-1, using the Venn diagram technique. First of all, step one, draw 3 overlapping circles and label each circle for one particular class. So the proposition contains 3 terms, mammals, mortal, and animals. So typically what you do is you put the circle for the middle term on the bottom, and then you put the circles for the subject and the predicate term on top, like this, okay? Now, you don't absolutely have to do this, okay? If you don't want. It doesn't really matter where you put the circles, but the tradition is to put the subject and predicate on top and the middle term on the bottom. So notice then that what we have are 3 overlapping circles. So the area smack dab in the middle of all of them is where all 3 intersect. Then there's an area where mammals and mortals intersect, an area where mammals and animals intersect, and an area where animals and mortal intersect. So what we're going to do is we're going to use this diagram here in order to characterize the categorical syllogism and then to find out whether it's valid or invalid. Okay, now what I'm going to do is draw in the 2 premises, okay? So let's go back to the syllogism. The first premise says says that all animals are mortal. So notice then that what I'm doing is I'm shading in everything in animals that doesn't intersect with mortal, okay? So again, I'm shading in everything in animals that doesn't intersect with mortal. All right. And so that says that all animals are mortal. The other premise was all mammals are animals. So for that premise, all mammals are animals, I shade everything in mammals that doesn't intersect with animals. So all that leaves is that little tiny area in the middle. So when you shade something in, that means nothing can be in that area. So here's the deal. Using the Venn diagram technique, a categorical syllogism is valid if in diagramming in the premises, you also get the conclusion, right? If you diagram in the premises and you don't get the conclusion, then the syllogism is invalid. So notice here, I diagrammed in the premise, all mammals are animals. I diagram the premise, all animals are mortal, and this is the diagram I get. The question is the conclusion in that diagram? So look at the conclusion again. The conclusion is all mammals are mortal. All right. Well, actually, what this the only place where there are mammals is where it intersects with mortal. So this, in fact, does say that all mammals are mortal. Therefore, we determined that the syllogism is valid, right? As I say here, a categorical syllogism is valid if in diagramming in the premises, the conclusion is also in the diagram. If in diagramming in the premises, the conclusion is not in the diagram, then the argument is invalid. Okay, and as I say here, using this rule, we can see that the diagram does in fact express the proposition that all mammals are mortal. Hence, the syllogism AAA-1 is in fact valid. Okay, so again, let's just go over this one more time. So my syllogism that I'm evaluating is all animals are mortal, all mammals are animals, all mammals are mortal. Okay, we said that that's a AAA-1. The middle term is animals. The major term is mortal. It's in the first premise, and the minor term is mammals. It's in the second premise. It's the subject of the conclusion. Okay, so then what we did is we put in three overlapping circles. Typically, customarily, you put the circle for animals on the bottom for the middle term, and you put the subject and predicate on the top, right? Again, it doesn't really matter where the circles go, but this is the customary way of doing it. And so now you have three overlapping circles. And now we're in a position to diagram in the two premises. So the first premise is one of the premises is all mammals are animals, right? And the other premise is all animals are mortal. So we shade, so for all animals are mortal, we shade in everything in animals that doesn't overlap with mortal. And if we say that all mammals are animals, we shade in everything in mammals that doesn't overlap with animals. So this is the diagram that we end up with. Okay, and so the question is, by diagramming in the two premises, did I also get the conclusion? And as it turns out, I did, because the conclusion is that all mammals are mortal. And this diagram here does in fact say that, right? Any place where there are mammals is also where there are mortals. And so all mammals are mortal. And so we say then the AAA-1 is in fact valid. Okay. Now let's try another one. With this syllogism here, it's figure 4, right? Because the middle term mammals is in a diagonal facing towards my right as I face the computer screen. So let's look at this one. Some animals are mammals, that's I, right? Some mammals are warm-blooded, that's I. And some warm-blooded creatures are animals, that is, again, I. So the mood is I, major premise, I, minor premise, I, conclusion. All right? So remember, always remember that for a categorical syllogism, the premise containing the predicate of the conclusion always comes first, and the premise containing the subject of the conclusion always comes second. All right. So now we look at this. We see, as we said, mammals is in a diagonal. It's a figure 4 syllogism, and all three components are I, and so therefore the syllogism is III-4. Okay, so now that and that's one of the things I'm going to ask you to do on this week's assignment. I'll give you a syllogism like this, and I'll ask you to do two things. One, tell me what the figure and mood is, right? So you go through the syllogism, you look at where the middle term is configured, and you fit it into one of those four figures, right? And then you see the mood. What are the propositions? You have four kinds of propositions: A, E, I, and O. So here, all three propositions are I. So it's I dash 4. All right. So that's the categorical syllogism. So now we're going to use Venn diagrams to see whether it's valid or invalid. And so let's go to the next slide. So again, remember what I said. You put the circle for the middle term, mammals, on the bottom, and you put the subject and the predicate term on top, right? So we have the subject predicate term and the middle term like this, and notice that they all overlap, right? Now what we need to do is to diagram in the premises, right? And if by diagramming in the premises we get the conclusion, then the syllogism is valid. If by diagramming in the premises we don't get the conclusion, then the syllogism is invalid. Okay, so one of the premises then is some animals are mammals, right? So that means we need to put an X in the area of intersection between animals and mammals. And notice, though, that the X will go on the line because the intersection has two subareas. So we put the X on the line to say that it could be in either subarea. Another premise, the other premise is that some mammals are warm-blooded, all right? Some mammals are warm-blooded. So what we do here then, what we do here is some mammals are warm-blooded. So what we're going to do is put an X in the area of intersection between warm-blooded and mammal. But notice here that the X will go on the area of intersection. So let's see if I can draw this in here. Okay. So again, for the premise that some animals are mammals, I'm going to put an X right here in between, right? In the area of intersection between animals and mammals. And I put it on the line because it could be in either subarea. So I don't know, so I just put it on the line. The next premise is that some mammals are warm-blooded, okay? So then that means that there's going to be an X in the area of intersection between mammals and warm-blooded. So I'm going to put an X right here on the area of intersection between warm-blooded and mammals. And notice that the X I put here is on the line again because it could be in either subarea. All right. So let's now go to the actual diagram. So that's exactly the diagram that we have. Now the question is the argument valid or invalid? Okay, so remember the criterion. The argument is valid if by diagramming in the premises, I get the conclusion. All right. If I don't get the conclusion, then the argument's invalid. So the conclusion is that so let's go back and see what the conclusion is. So the conclusion is some warm-blooded creatures are animals, okay? Some warm-blooded creatures are animals. That means that there has to be an X in the area of intersection between warm-blooded and animals. But notice that the X's are on the line. They're not decisively in this area of intersection. So is it valid or invalid? In fact, the argument is invalid, right? Because the X, there is no X in the area of intersection between warm-blooded and animal. The one of the X's is on the borderline between, for example, mammal and animal, and the other one is on the borderline between mammal and warm-blooded, right? So therefore, there's no X decisively in the area of intersection between warm-blooded and animal. And so we say that this syllogism is invalid. We did not get the conclusion by diagramming in the premises, right? So as I say here on this slide, the conclusion is not in the diagram, given that both X's could be in either subarea. Neither X is decisively in the area of intersection between the circles for the minor and the major terms. Okay. All right. So hopefully everybody's clear. So you can get two types of diagrams. You can get diagrams where you shade stuff in. That's for the universal affirmative and universal negative. And you did get diagrams where you put X's, right? And that's for some and some not. All right. So in the argument we just looked at, we diagrammed in the X's. Again, very important. You put the X on the line, right? Because it could be in either subarea. And the same thing for the second X. You put it on the line because it could be either subarea. You don't know which. But the problem is if it's on the line, it's not decisively in this area here. And if it's not decisively in that area there, then it means that the argument is not valid, right? Because you don't get the conclusion by diagramming in the premises. Okay, so what I want to do next is to teach you a second technique for assessing categorical syllogisms, okay? This is called the rule technique. And it's, and so basically it's equivalent to the diagram techniques, right? But before we get into how to develop this technique, we need to define a very important term. The term that I want to define for you is the term distribution or distributed, because two of the five rules use the term distribution. So we need to get clear on what distribution is. So here, let me give you a formal definition. A term in a categorical proposition is distributed, means that the proposition refers to all members of the class denoted by the term. All right. So consider the A proposition, all S's are P's. The proposition refers to all S's, but it doesn't refer to all P's. The S term is distributed because the proposition refers to all S's, but the proposition does not refer to all P's. And therefore, we say that the S term is distributed and the P term is undistributed. The proposition refers to all S's, but it doesn't refer to all P's. Now let's go to the E proposition. No S's are P's, okay? Well, both terms are distributed, right? It's talking about all S's and all P's. In other words, no S's or P's is the same thing as all S's or non-P's. The term is, both terms are distributed, right? A way of thinking about it is that no S's or P's is the same thing as no P's or S's, right? So therefore, if S is distributed, then so is P, because they're you can they're interlocatable, as it were. They're convertible. Okay. So the proposition no S's or P's is talking about all S's and it's talking about all P's. So in the E proposition, both terms are distributed. Okay, so once again, in the A proposition, the S term is distributed and the predicate term is not distributed. In the E proposition, the S term is distributed and the P term is distributed. Now consider the I proposition, some S's or P's. This proposition is talking about some S's and it's talking about some P's. So therefore, neither S nor P are distributed. Remember that all that distribution means is all. Because we're not talking about all S's and we're not talking about all P's, then neither term is distributed. So in an I proposition, neither term is distributed. Okay. Now let's go to the O proposition. The O proposition, some S's are not P's. Clearly the S term isn't distributed because it's only talking about some S's. What about the P term? Well, just take this on faith, an article of faith, okay? When you have a no proposition, the predicate term is regarded as being distributed, okay? As I say here, the P term in a no proposition is stipulated to be distributed. The pragmatic justification is that the rule technique wouldn't work otherwise, right? So it's a purely pragmatic justification, all right? So anyway, don't try to, I mean, you know, a more intuitive justification is that the proposition is saying that no P's are S's for some S's, but frankly, don't worry about that. Just take it on as an article of faith that in a no proposition, the S term is undistributed and the P term is distributed, okay? We can summarize this in the following little table, right? All S's are P's, universal affirmative. The S term is distributed and the P term is undistributed. Why? Because the proposition refers to all S's, but it doesn't refer to all P's. Now let's go to no S's or P's. The S term and the P term are both distributed. It's talking about all S's and it's talking about all P's. If I say that no lizards are mammals, that's the same thing as saying no mammals are lizards. It's the same thing, right? So if S is distributed, then so is P. So both terms in the E proposition are distributed. And remember that for the I proposition, some S's are P's. It's only talking about some S's and it's only talking about some P's. So both terms are undistributed. In the proposition, some S's are not P's, we say that the S term is undistributed because it's only talking about some S's, and the P term is distributed by convention, just by stipulation, okay? Don't worry about trying to justify it, just as I say, it's an article of faith. So to summarize, you can distinguish the four kinds of propositions in terms of either their quality and quantity, that is universal affirmative, universal negative, particular affirmative, particular negative, right? Quantity and quality, or you can distinguish them in terms of distribution of terms. An A proposition, both S is distributed, P is undistributed. In an E proposition, both terms are distributed. In an I proposition, neither term is distributed. In a no proposition, the S term is undistributed and the P term is distributed. And so this is, and again, all that distribution means, don't get all bogged down by the technical definition of distribution. All that distributed means is the proposition refers to everything denoted by the term, right? So all S's are P's, I'm talking about all S's, but not all P's. No S's are P's, I'm talking about all S's, I'm talking about all P's. Some S's are P's, I'm only talking about some S's, and I'm only talking about some P's. Some S's are not P's, I'm talking about some S's, but all P's. And so this then is an important concept. And the reason we need to know this is because it occurs in two of the rules for assessing categorical syllogisms. So we are now then in a position to list a set of rules that you can use for evaluating categorical syllogisms. A rule that, as I say here, is equivalent to the Venn diagram technique we learned earlier today. All right. So here are the 5 rules. Let's go through each of them. The middle term must be distributed in at least one premise. So that means that if a syllogism is valid, the middle term that occurs only in the premises, at least one of the premises must be talking about all of it, right? The middle term must be distributed in at least one premise. Rule number 2, any term distributed in the conclusion must be distributed in the premise. So if I say, let's say I have some S's are not P's, then P must be distributed in the premise in which it occurs. Any term distributed in the conclusion must be distributed in the premise. So that's why it was important to go over the concept of distribution, because it occurs in the first 2 rules for assessing categorical syllogisms. Okay, rule number 3. No valid syllogism has 2 negative premises. Okay, negative would be what? There are 2 kinds of negative premises. There's E, universal negative, and there's O, particular negative, right? No valid syllogism can have 2 negative premises. Okay, rule number 4. If you have a syllogism with a negative premise, it has to have a negative conclusion. Or if you have a syllogism with a negative conclusion, it has to have a negative premise. And rule 5, sometimes it's called the existential fallacy. 2 universal premises in a Boolean syllogism require a universal conclusion. So if I have AA, then the conclusion must itself be universal. I can't have AAI because I have 2 universal premises, but a particular conclusion, and that violates rule 5. So, long story short, a syllogism is valid if and only if it satisfies each of those 5 rules. A syllogism that satisfies each of those 5 rules will also have a Venn diagram such that if I diagram in the premises, I'll get the conclusion. So there's a complete 100% one-to-one correlation between the rule technique and the Venn diagram technique. Okay, just let me repeat that. Again, if a syllogism passes all 5 rules and therefore is valid, then when you diagram the syllogism using the 3 circles, the Venn diagrams, by diagramming in the premises, you will get the conclusion if it's valid. Suppose a syllogism violates one of the 5 rules, then the syllogism is invalid. And that means that the diagram for the syllogism will be such that if you diagram in the premises, you will not get the conclusion. So there's a one-to-one correlation between the rule technique and the Venn diagram technique. So let's go back to AAA-1. Remember we did the Venn diagram for that? And it turned out that by diagramming in premise 1 and 2, I got the conclusion. But it also passes all 5 rules. It is valid. Okay, let's go back to the 5 rules, all right? Let me convince you that it's valid. Well, first of all, the middle term animals is distributed in the first premise. So it's valid, right? It's distributed in the first premise. So it is valid. Also, the term mammals is distributed in the conclusion, but notice it's also distributed in the premise in which it occurs. So it passes rule 2. Moreover, you do not have two negative premises. So it passes rule 3. And it passes rule 4 because you don't have any negative premises or conclusions. And finally, rule 5 says that if you have two universal premises, you need to have a universal conclusion. And in fact, we do. So AAA-1 passes all 5 rules, and so it's valid. And also the diagram for it is valid as well. Okay? So let's go back. Let's just go back, if I may, to the diagram for AAA-1. Sorry, we're going back several slides here. Okay, there was a diagram for AAA-1. Notice at the conclusion, all mammals are mortal is in that diagram. And in addition, we saw that it passed all 5 rules. The middle term is distributed at least once. The subject term that's distributed in the conclusion is also distributed in the premise in which it occurs. It doesn't have two negative premises. And finally, you have two universal premises and you have a universal conclusion. So the diagram shows it to be valid. You get the conclusion by drawing in the premises, and the rules show it to be valid. Okay? So let me go back now to the slide we just left off from. Sorry there. Okay, so there it is. All right, so AAA-1 is valid, both according to the Venn diagram technique and according to the rule technique. All right, now let's look at III-4. My apologies, III-4. All right, so III-4, we've already looked at this, is some animals are mammals, some mammals are warm-blooded, some warm-blooded creatures are animals. Remember that we diagrammed that, and by diagramming the premises, we did not get the conclusion. Therefore, we concluded that this argument is invalid. Now, let's look at the argument and go through all the rules. Rule number 1. The middle term must be distributed at least once. Notice that it fails that rule, right? The term mammal, which is the middle term, is not distributed in either premise. So we know that that syllogism is invalid, okay? So it fails the distribution rule relating to the middle term, okay? Let me just do an impromptu diagram. Instead of going back a bunch of slides, let's just redo the diagram, okay? And my apologies for my terrible handwriting. Be glad that my PowerPoint lectures are typed and not handwritten, okay? Okay, so therefore we have W for warm-blooded, okay? We have A for animals. So this is your subject and predicate term of the conclusion. And then the middle term on the bottom is mammals, okay? So let's do the diagram for this. So if you say that some animals are mammals, all right, then you're going to put the X right here in the area of intersection. And you're going to put it on the line because you don't know which subarea it's in. Some mammals are warm-blooded. You're going to put the X in the area of intersection between mammals and warm-blooded, but because you don't know which subarea it's in, you put the X on the line here. Okay, so notice that this argument is invalid because by diagramming in the premises, I did not get the conclusion. To get the conclusion, the X's on the lines would have to be decisively in that area between W and A, but it's not, and so the argument is invalid. So again, as noted, the diagrams and the rule technique always match up one-to-one. Whatever result you get with the rules, you get with the diagrams and vice versa. Okay? So as I say here, our III-4 syllogism violates rule 2. Actually, sorry, that should be rule 1. My apologies. That's a typo. Rule 1, the middle term is undistributed in both premises. Okay? So what these two examples illustrate is that the Venn diagram technique and the rule technique agree. They coalesce. Now let's consider the following syllogism. AAA-4. Is it valid or invalid? Okay. Well, let's see. First of all, why don't we do the diagram for this, all right, and see what happens when we do the diagram. Well, okay, I'll tell you what. Before we do that, let's recover its structure. Remember I taught you how to do that last week? Here's the structure. All P's are M's, all M's are S's, all S's are P's. Okay, so that is AAA-4. Why is it -4? Because notice that the middle term is configured in a diagonal towards my right, facing the screen. So it's a figure 4, right? And it is all three propositions are A. So it's A, major premise, A, minor premise, A, conclusion, dash, figure 4. Okay. We can see that this syllogism is invalid. Why? Well, because it's invalid. Because look what's going on here. All right. Although the middle term is distributed in the second premise, the subject of the conclusion is distributed, all S's, but it's not distributed in the second premise. All M's or S's talks about all M's, but it doesn't talk about all S's. So it fails that distribution rule. And so the syllogism is invalid, right? So AAA-4 is invalid because it violates the rule that a term distributed in the conclusion must be distributed in the premise in which it occurs. Now, if we do the Venn diagram, this is what we get. Okay, so again, all P's are M's, so I shade in everything in P. Sorry, I shade, let's just go back to this again. All P's are M's, so I shade in everything in P that doesn't intersect with M, right? Okay, and the other premise is all M's or S's, so I shade everything in M that doesn't intersect with S, okay? So that just leaves this little area here, and this little area, and then this area here. Okay, now the conclusion is all S's are P's. All S's are P's. This diagram doesn't say that. So how do you diagram? Let me just convince you of this, okay? Sorry again for my terrible hand drawing. Okay. Boy, that talk about bad writing, eh? Okay, S, P, and M. Okay. I should have been a medical doctor because I have such terrible handwriting. All right. So if I wanted to have all S's or P's, which is the conclusion, then I would have to have this. All S's or P's would have to have all of this shaded in here, right? But notice that that's not what I get in my diagram. In other words, by diagramming in my premises, I don't get the conclusion. And what I've just drawn for you here is the conclusion. Therefore, we can say that the syllogism is invalid, right? Okay. It violates, again, the rule that any term distributed in the conclusion must be distributed in the premise in which it occurs. And although the conclusion is talking about all S's, the premise is not talking about all S's. And therefore, it violates that rule. And in addition, by diagramming in the premises in the Venn diagram, we do not get the conclusion. Therefore, the argument is invalid. Sometimes you don't even have to recover the structure of a syllogism. If I just give you this information here, you can tell without recovering the structure. Let me convince you of this. O-3. I know right away it's invalid. Why? Because it has two negative premises. Remember the rule? No valid syllogism has two negative premises. Okay? Look at the one below it, EOE-4. It's invalid for the same reason. I have two negative premises. EEI-3. It's invalid because I have two negative premises. And in addition, I don't have a negative conclusion, so it violates two rules. It also violates Rule 5 because I have two universal premises and a particular conclusion. So this one violates three rules. But just keep in mind, a syllogism is invalid. It just needs to violate one rule, right? But the EEI-3 violates 3 rules. It has 2 negative premises. It has negative premise, but not a negative conclusion. And it has 2 universal premises and a particular conclusion. So it violates 3 rules altogether. Now let's look at let's look at the next one, AAI-4. I don't need to do anything there. I know right away it's invalid. Why? Because it violates Rule 5. From the Boolean stance, 2 universal premises require a universal conclusion. But here I have a particular conclusion. So syllogism AAI-4 is also invalid. Okay? Is everybody with me so far? All right. Okay. Now what about EAO-3? You'd say, well, I mean, it's got a negative premise and a negative conclusion. It doesn't have 2 negative premises. Here's the problem. It has 2 universal premises, right? EA are both universals, right? Universal negative and universal affirmative. And it has a particular conclusion, some S's are not P's. So we know that this syllogism is invalid because it violates rule number 5, that 2 universal premises requires a universal conclusion. Finally, let's look at EOI-4. Again, we know that this is invalid. Why? Because it has 2 negative premises. Moreover, it has a negative premise, but doesn't have a negative conclusion. So sometimes you can just look at the syllogism and tell right away whether it's valid or invalid using the rule technique. Okay. By the way, this is called McDonald's rule. All EIO syllogisms are valid. EIO, right? So whenever you get an EIO syllogism, it's automatically valid. Okay. Okay. So let's look at these 2 syllogisms here. Are they valid or invalid? So let's why don't we unpack these? Okay. I'll draw it in again with my terrible handwriting. All right. So let's do EAE-4. So that is no P's are M's, right? No P's are M's. Okay. So that's okay. And the second premise, the major premise, is all M's are S's, right? All M's are S's. And then, of course, the conclusion is no S's are M's, okay? No S's are P's, rather, sorry. Okay? So there it is. So let's take a look at this here. Well, is it valid or invalid? Well, first of all, you have a negative premise, but you have a negative conclusion. You don't have 2 negative premises. It looks pretty good so far. You have 2 universal premises, but you also have a universal conclusion, so that looks good. So the only rules we need to concern ourselves with are the distribution rules. So let's just see here. Notice that P is distributed in the conclusion and is distributed in the premise in which it occurs. The middle term is distributed in the second premise, so that rule is passed. The problem is with the subject term of the conclusion. No S's or P's. S is distributed, but if you look at the premise, S is undistributed. So this syllogism is in fact invalid. Okay? Now let's diagram it. I'll show you, you're going to get the same result using the Venn diagrams, okay? Okay, so let's just do a crude diagram here. So I'm going to put the 3 circles, okay, like so. Okay, and I'll put S, P, and M is always on the bottom, right? Okay, so let's do the diagram for it. Now, if we were right with the rule technique, then by diagramming the premises, we should not get the conclusion. So let's diagram in the premises. First of all, the first premise is no P's are M's. So no P's are M's. So that I'm going to shade in the area of intersection between P and M. And that tells me that no P's are M's. Okay, so I'm shading in this area here. The second premise is that all M's are P's. So that means I shade in everything in M that doesn't intersect with P. So let's just make sure I did this right here. So no P's or M's, right? So I shade that in there, okay. And then all M's are P, so I'm going to shade in everything in M that doesn't intersect with P. Okay, all right. So that says that all M's are P's, all right. And this here says that no P's are M's. Notice that I don't get I don't get no S's or P's because this area, there's an area here, namely this area here is still empty, right? And so if I were to say that no S's or P's, this area would all have to be shaded in. So the syllogism then is invalid. Let's look at EAE-1. It's the same mood, but just different figures. So let's see what this one looks like. So EAE-1. So this will be no M's or P's, right? And the premise will be all S's or M's. And notice that it's a figure 1, so the M is on a diagonal, but this time towards my left. And then the conclusion, of course, is no S's or P's. Okay, so what about this one? Well, okay, so let's first of all, it's just like the other one. None of the negation rules are violated. You don't have two negative premises, and you have a negative premise and you have a negative conclusion, so that's good. You have two universal premises, but you also have a universal conclusion. So the only rules we have to look at are the distribution rules. Is the middle term distributed? Yes, it is in the first premise, so it passes that rule. And both S and P are distributed in the conclusion, right? Are they distributed in the premises? Yes, they are. P is distributed in premise 1 and S is distributed in premise 2, and so the syllogism is valid. So EAE-4 and EAE-1, even though they have the same mood, the 4 is invalid and the 1 is valid, okay? Why don't we do the diagram, all right? So here's a diagram. What should happen, given our results of the rules, is that by diagramming in the premises, we should also get the conclusion. Okay, so let's do the diagram for this one. Once again, it's SP and M on the bottom, right? Okay. Okay, so once again, the first premise is no M's are P's. So that means we're going to shade in this area here. No M's are P's, right? Just like with the first one. Now we have all, yeah, no M's or P's. And then we have all S's are M's. So all S's are M's. We shade in this area here. Okay, so that's the final diagram, all right? Notice that the syllogism, that the conclusion is in here. By diagramming in the two premises, I got the conclusion. Notice that the area of intersection between S and P is completely filled in, and that says that no S's are P's. All right, so again, I get the same result using the diagram that I got using the rules. So this tells me then that although EAE-4 is invalid, because it violates one of the distribution rules, and because by diagramming in the premises I don't get the conclusion, EAE-1 is valid because it doesn't violate any of the rules. And when I do the diagram, when I diagram in the premises, I get the conclusion. All right. And so that is the Venn diagram technique and the rule technique for assessing categorical syllogisms from the Boolean stance. All right. Now, the Aristotelian stance is going to differ a little bit, and we'll go over that in next week's lecture. But for today, all that I want you to know is how to assess syllogisms using from the Boolean stance using Venn diagrams and the rules. And that is what your assignment is for this Thursday. All right. So based on this lecture and based on the PowerPoints that correspond to this lecture, you should be able to do the assignment that's due this Thursday. Okay. All right. So have a great week, and I will post again next week. Thank you.